Hi. Alright, okay, let's try this question. Pause the video, alright, copy down the question and try the question. So a normal random variable, or we said that a normal distribution, has a mean and a standard deviation sigma. If probability of x more than 12 is 0.3 and probability of x less than 6 is 0.4, find the values of mean and the standard deviation. Right? So based on the question, it's clearly state that it's a normal distribution. X is a continuous random variable with normal distribution of mean and standard deviation. For normal distribution is defined with mean and variance, right? Variance. So as given that the probability of x more than 12 will be 0.3, right? Will be 0.3. So from here, we want to find the value of mean and the standard deviation, which is two unknown, right? So okay, let's see what can this help you, the information here. So we have to convert into standard score in order to using the statistical table. So convert to standard score, which we're taking the 12 minus with the mean divided by the standard deviation, right? The sigma here, which is equals to 0.3, right? So we're using the formula of x equals to x minus with mean divided by the standard deviation here. So and I let this to be a k, right? A k. So I let this to be a k for now. I let this to be a k, which 12 minus mean over with sigma here, right? So I know it's 0.3, right? More than k. So more than k, and the area here is just 0.3, right? As you know that if this is a distribution, a normal distribution, if you standardize, it's become a z-score, it will be 0 at the middle. So 0.3, more than means on the right, So I'm not drawing this, okay? There are two possibilities, either is on the, right, more than, there are two possibilities, the value of k and the value of k, it can be something that greater than 0.5, or it can be the area that less than 0.5. Half of this, half of the area here, this area here, everything here, the area here, can I see my hand? I shade it here, is 0.5, but this is just 0.3. Definitely this will be the distribution, right? The k will not be here. The k will be here if the value of 0.3 is more than 0.3, more than 0.5. For example, 0.6. If I see the value here is 0.6, 0.51, 0.9, 0.8, any number that more than 0.5, it will be on the left hand side of the mean 0. Because why? The area should be more than 0.5, right? Definitely this is not for this case, right? It's not for this case, it's just 0.3. All right, you have to clearly know about this. All right, okay. Now we know that from here, we know that it's already on the upper tail, right? So if it's on the upper tail, we can straight away using the table 3, the table of standard normal distribution. You see that 0.3, right? 0.3. But there is no value of 0.3 here. If you observe carefully here, this is 0.3015 and this is 0.2981. So you should not round off if possible. We try to avoid rounding off for example, this one can become 0.3, this one also can become 0.3, right? So there is a two choice. So we try to avoid this type of cases. So if there is no value of 0.3 here, so we try to look at table, instead of looking at table 3, we try to look at table 4, right? At the end of the page of the statistical book for matriculation. So table 4, table of percentage point. So you look at here is 0.3, right? So 0.3 is correspond to 0.5244. So means that the value of k here should be 0.5244. 0.5244 from the table 4, right? From table 4. From table 4. So now we have the value of k. The k is 12 minus with mean divided by sigma, which is 0.5244. Now we have get an equation that relate mean and the standard deviation, right? We're going to form an equation for this. So it's a linear equation. So we have 12 minus mean. 12 minus mean equals to 0.5244. 0.524 multiply with sigma. Multiply with sigma. So I bring the mean go to the other side. Mean negative become positive mean plus with 0.5244 sigma equals to 12. Now we have equation, right? Equation that relate mean with the standard equation, the standard deviation. But there is two unknown here, so we need another relationship. We need another equation. So in order to find the value of mean and standard deviation, all right. So it was come from the question, the information. The next information will be from here, from the px more than 0.3. I have already explained to you. We have getting the first equation. So now we look at the probability of x less than 6 is 0.4. All right. Okay. Let's look at the next information. The next information will be probability of x less than 6, which is 0.4, right? 0.4. Now it's less than, right? So we have to standardize the score here if we use normal distribution table, right? So we have to write this 6 minus with the mean divided by the standard deviation, which is 0.4. So again, I'm going to let this to be k. It's a k, another k for this, okay? Another step. So it will be 6 minus mean over with standard deviation. The k is just a variable to help me solving this problem here. So pz more less than k, right? Which is 0.4, right? 0.4. So I try to find the value of k here before I find the value of mean, right? But this is less than, right? Less than. So there is two possibility, okay? Okay, this is for my teaching, right? This is for teaching. This is not a working, right? This is for me to explain to you so that you have better understanding here. So sometimes you need some time to understand this. So k, right? So you know that the score is always 0 because this is a standard score, right? Standard score, the mean will be 0. And less than k, right? Less than k can be this small part here, or the less than k can be, less than means on the left, right? On the left, the area on the left. More than means the area on the right. Okay, now if this is less than means that it's either this or this one. So to decide either A or B, untuk tentukan sama ada A atau B, we look at this value, 0.4. 0.4 is less than 0.5, right? This is 0.5, right? This is 0.5. This, if the k is here, it should be more than 0.5, right? But this is just 0.4, so this should not be the distribution. So this will be the one, right? This will be the one where the k is on the left hand side of the 0. It's a negative number here, all right? It's a negative number here. So now how to understand this in order to solving the problem here. So because it's on the left, if we want to using statistical table for matriculation, we have to convert it into an upper tail. Means that it's always have to be something on the right of 0. So this one you have to reflect it to the left, to the right. From k here, it becomes negative k here. Usually students will confuse here. Why teacher put negative k here? Why there is a negative k here? Definitely, if you from a negative become a positive 0, right? This is 0. So this is on the left of 0. It should be negative, right? It should be negative. So in order, k is a negative value. K is a negative value. So if you reflect it onto the right hand side, it should be a positive value, right? It should be a positive value. That's why we have to multiply. This is a negative value. We multiply a negative, it will become positive, right? Negative k is a positive value. So for example, okay, for example, if you have negative 2, right? You have negative 2. So it's the same as the area on the right, right? It's the same, okay? These two areas are the same. They are symmetrical about the mean. So negative 2 and the 2 here is the same. That's why I convert the k here on the left side to the right hand side. I put a negative k because you see, this is negative 2, right? Negative 2. So I have to put a negative of the negative 2, right? Of this k, So in order to become positive 2, right? That's why I have to put a negative k. That you must understand. Alright. So means that I already know that the pz less than k here, the pz less than k here can be rewrite, the pz less than k here can be rewrite is the same as pz more than negative k, right? This is the same as this, right? One on the left and one on the right. The area is actually the same, right? If you want to use statistical table, it must be on the right. So negative k will be 0.4, right? Now we just find the value of negative k is already greater than, so find the value of negative k from the statistical table here. So again, this is also using the percentage point because the value here is very nice, right? 0.4. So you can find from the table 4 here, 0.4. So 0.4 is correspond to 0.2533, right? 0.2533. 0.2533. So then the value of k here will be negative 0.2533. So we have to know that the k, for this case here, the k is 6 minus mean. 6 minus with mean over with standard deviation equals to negative 0.2533. So we try to get another equation. So you put it, multiply the sigma. 6 minus with mean is the same as negative 0.2533 sigma, right? So if you move this to the other side, you are getting another relationship which will be mean, positive mean minus with 0.2533 standard deviation equals to 6, and this will be equation 2. Equation 2. So now we continue by solving these two simultaneous equations, where the first one will be the mean plus with 0.5244 sigma is 12, equation 1, and equation 2 will be mean minus with 0.2533 sigma, which is equal to 6, equation 1 and 2. I think this should be not a problem for you to solving this equation. So as you see that using elimination method, the mean, so I eliminate the mean, right, in order to find the sigma here. So I'm taking equation 1 minus with equation 2, all right? So why minus? Because there is a mean, right? Same coefficient, so in minus minus mean, you're getting 0, and 0.2552, right? 0.5244 sigma minus with negative 0.2533 sigma is equals to 12 minus 6. 12 minus 6, you have 6, right? Total up these two, right? Total up these two, you were getting 0.7777 sigma, right? 0.47, which is equal to 6, and the value of sigma, you're taking 6 divided by 0.7, you are having a value of 7.715 here in 3 decimal places, right? 3 decimal places here. So now you have know the value of standard deviation, right? You have know the value of standard deviation. Definitely you can know the value of mean also, right? You can substitute to either one of these two equations, right, to get the value of mean here. So the value of mean, I can using equation, right, from equation 1, right, from equation 1. So mean is the same as 12, right? 12 minus with 0.5244 times with sigma, right? The sigma, the value of sigma, the standard deviation, you know, is 7.715, right? 7.715. So then at the end, you were getting in 3 decimal places, the mean will be 7.954, right? 7.954. So this is the value of mean, and this is the value of the standard deviation, right? As the question requests you to find, the value of mean and the value of standard deviation, which is 7.954, and another one will be 7.715. All right, that's all for this question.